400 years after Galileo's first telescope, we are on the verge of a new way of looking at space, which will open up new frontiers in astronomy. This will be achieved through the observations of gravitational waves, predicted by one of the most revolutionary theories in physical sciences, Einstein's general theory of relativity, which was proposed exactly 100 years ago. And in this film, we will introduce the basic ideas, current developments, highlights and contributions made by Indian scientists in this theory. In March of 1944, Einstein had humorously quipped, "Why is it that nobody understands me, yet everybody likes me?" The domain of general relativity is complex and esoteric. However, now it has become so pedantic that it is literally in the hands of 2.6 billion people in forms of smartphones having GPS. So the next time when you're using maps on the phone to navigate to your friend's house, please bear in mind that the GPS technology works accurately only because of Einstein's general theory of relativity. Oh, and Einstein also said that to lose weight, we need to slow down. So instead of pumping weights and flocking at the slimming centers, you just need to slow down. Let's try to dig a little deeper. Consider a flat, checkered, stretched sheet of cloth. Now if you place a heavy ball on it, the fabric stretches and curves in response. And if you throw a lighter ball at fast speed, it will roll around the heavier ball due to the curvature in the fabric that the latter has induced. And this is exactly why the Earth goes around the Sun. The importance of Einstein's GR is that it recognizes space-time as the four-dimensional fabric of the universe and gravity as the curvature of space-time. Now, just like any moving charged particles radiate or release energy in form of light, which is visible or otherwise, objects moving around each other will also release energy. This released energy is the gravitational wave. Ripples in that fabric of space-time are much like the ripples of water in the river or ocean. Aha! And if we can see or measure or locate these waves, we can get a new view of the universe which can be path-breaking. So the next time you circle around your friend holding their hands tightly at high speeds, remember that you are also radiating waves, the gravitational waves. And so one can ask that if we are radiating energy, we will keep losing energy and collide into each other. This might take millions of years because the gravitational waves are extremely weak. And so the chances are that you might feel exhausted or dizzy in just a few minutes. These waves are extremely feeble because of the masses involved and so cannot be observed. And that is the main problem in detecting gravitational waves. But what if two black holes collide? Or twin stars circle around each other? Then they would radiate gravitational waves which are strong enough to be measured. And by measuring these waves, we could see what no man or woman has seen before. Even these stronger gravitational waves would require extremely sophisticated instruments to be able to measure deflections of about 10 to the power minus 18 meters, much smaller than the size of the atomic nucleus. The deflection data generated by these instruments is very feeble and hence contains a lot of noise, seismic noise, airplanes flying by, traffic noise, even a school band playing nearby can corrupt the data. So to detect and extract the gravitational wave, we need to have really smart algorithms or methods which can extract pure gravitational wave from the noisy data. And this is where the Indian scientists figure in. The method to detect and extract gravitational wave was developed by a team of scientists at IUCAA and is now used universally across the world. Extraction process requires very accurate phase information of the wave, which was done by the scientists at RRI. Indian scientists have made many other significant contributions in gravitational wave research, like developing an understanding of black holes, strategies to look for unknown sources, identifying and mitigating instrumental glitches, following up on potential gravitational wave events, and electromagnetic telescopes. we have not yet detected a gravitational wave, but we are very close with the help of laser-based detectors called LIGO. Two of these have been constructed in the US, 3,000 kilometers apart. But the holy grail in gravitational waves is to detect one and also locate the source of the wave in the sky. Now, to exactly locate the source of the wave in the space, we need to have another facility much farther away. By getting the data of the same wave from 3 detectors far away, we can triangulate and exactly locate the source of the gravitational wave. And hence, we can follow up the source using other telescopes and means. India is on the other side of 2 LIGO detectors based in the US. And so, if we build a LIGO in India, we will be able to improve our accuracy of finding the source by a factor of 10. And so, we are at a very interesting phase in astronomy, where India can play a major role. With some of the most fundamental research in gravitational waves, general relativity supporting us, the geographical advantage of being the farthest from the current detectors, we can take a lead and pave way for many fundamental discoveries in our understanding of cosmos and testing basic scientific theories. Even the general theory of relativity, of which we are celebrating the centenary. And so all this work in gravitational wave astronomy will provide a platform for many Indian scientists and youngsters to collaborate in our quest for beyond. Thank you.